The next part is section 2. We are done with section 1. Next one is section 2. That is measurements in an experiment. Like when we are making an experiment, we have measurements. Like we may be asked to measure the length of an object, the volume of an object, the area of a given space. So how do you measure in an experiment? What do we use to make an experiment? So the description of what kind of physical quantity is represented. Is it by a certain measurement? It's called dimension. So you should know the meaning of dimension. A dimension is a description that helps us to define what kind of physical quantity is represented. And there are 3 basic dimensions. This is very important. We have 3 basic dimensions. Basic. I'm not saying there are only 3. We have 3 basic dimensions. These are length. First dimension is length, which is symbolized by capital letter A. Next is mass. And time. This is T. So these are the 3 basic dimensions. Sometimes we can use, by the way, these are the 3, but we can also add temperature and current. When there is heat and electricity. But the 3 basic dimensions are mass, length, time, and sometimes temperature and current. For example, you may be given a physical quantity, and you may be asked to express the given physical quantity in the dimension form. What are the dimensional? For example, write the dimensions of speed. For example, speed. To find the dimension of speed, we start with the definition of speed. What is the meaning of speed? The speed is defined as the rate of distance traveled. That is, distance divided by time taken to cover that distance. Symbolically, I can use the speed V is a symbol for speed, which is the same as the distance is S. Sometimes I can use L, because the distance between 2 points is the same as the path length between these two, or the state length. The distance from A to B means this state path. So distance S is the same as I can use L. So the dimensions of speed are L divided by T. This is the dimension of speed. Let me give you another example. What are the dimensions of example 2? What is the dimension of acceleration? So to find the dimension of acceleration, we have to start with the meaning of acceleration. We know that acceleration is defined as the rate of change of velocity. So to find the dimension of acceleration, I have to use the dimension of velocity and the dimension of time. We already know that the dimension of velocity is already calculated I have already shown in the above example, which is L divided by T time over T is capital letter T. Now we have to simplify this ratio, which is equivalent to, I can rewrite this as L divided by T divided by T. I can write this as T over 1. So this is equivalent to L over T. Whenever we are changing this division to multiplication, I will reciprocate the second expression, that is 1 over T. So this is equivalent to, I can write this as L multiplied by 1, I will multiply the numerators together and denominators together. That will be L times 1 is L divided by T multiplied by T is T squared. This is the same as in some books, or you can rewrite this as LT minus 2. This is the dimension of acceleration. That's all how to find. This is a way how to find the dimension of a given physical quantity. You can add, if you like, you can find the dimension of force, work, power. So this is a way how to calculate the dimension of a given physical quantity. Next to this is, what are the two types of physical quantities? In our previous lesson, we defined what a physical quantity means. Physical quantities are quantities that can be measured and expressed in number. We can measure them. After we measure, we express by a number and a unit. So physical quantities are quantities that can be measured and expressed in number. And we have two types of physical quantities. One is basic physical quantity, the other one is derived physical quantity. So why do you call them basic? Basic quantities are quantities that can be measured directly. We can measure them directly. And the best examples of basic physical quantities are, by the way, the basic physical quantities are 7 in number. The basic ones are mass, length, time, current, electric current, temperature, amount of a substance, and luminous intensity. These are the 7 basic physical quantities. The remaining other quantities are derived physical quantities. We call them basic because the remaining other quantities are expressed as the product or quotient of these 7 physical quantities. Product or quotient of these 7 physical quantities. That's why we call them basic physical quantities. The second type of physical quantities are derived physical quantities. These are quantities that cannot be measured directly. We can't measure them directly. We measure them indirectly by calculating the basic physical quantities. And examples of derived physical quantities are speed, acceleration, force, work, power, etc. So these are the two basic physical quantities that we have. One is basic, the second one is derived.